Hi, in this video I will be discussing the sine wave, its characteristics, and the general equation for the current and voltage for AC circuits. For DC circuits, we know that the polarity and magnitude of voltage remains constant over time, so a constant current flows in one direction. The result of this is a straight line graph for the current as well as voltage. However, for AC circuits, the voltage constantly changes polarity, therefore the current increases, reaches a maximum value, decreases, flows in the opposite direction, reaches a minimum value, and then increases again. The overall result is a sine wave, and the wave keeps repeating itself. Taking 0 as the reference point, the peak amplitude is the difference between the maximum point on the wave and the reference point. Peak to peak amplitude is the difference between the maximum point and the minimum point. RMS amplitude can be calculated by dividing the maximum point by √2, and the time period of a wave is the time it takes for it to complete one complete cycle. This can be determined directly from the wave or by making use of the frequency or the angular velocity of the wave. These two equations can help you determine either the current or voltage at any given moment, where theta is the phase shift of the sine wave. Take two equations A and B, for example, with theta as the phase shift of A with respect to B. If theta is positive, A is shifted to the left and A leads, and if theta is negative, A is shifted to the right and B leads. In this example, to calculate the time period, you take the number right next to the t. This will give you your angular velocity. Since we know the relationship between angular velocity and the time period, we can use it to calculate the time period of the wave. Since the angular velocity is the same for both the waves, the time period will be the same as well. To calculate the RMS value of the voltage, you take the maximum possible value of the voltage and you divide it by √2. Since we know that a sine wave is a cosine wave shifted to the right by 90 degrees, to convert the cosine function to a sine function, we add 90 degrees. And then we take the difference of the two angles to find the phase difference. Since the current is shifted to the left and the voltage waveform is shifted to the right, in this example the current leads. I hope this video helped. Thanks for watching.